Hello. In this video, I'm going to go through what you're going to need to know for the second exam. This is our mini exam that's covering chapters 8, 9, 10, and 13. And so I've pulled up the mini study guide that I created here, and I want to go through what the exam looks like um, and just some general information that you need to know in terms of how to study and prepare for the exam. In a separate video, I will actually create a walkthrough of the study guide itself in terms of the practice test and give you an idea of what that might look like and certainly how to do all the problems and get the correct answers for your own purposes. But for this video, we're just focusing on what does the exam look like and how do you get yourself ready to take that exam? So, first and foremost, the exam itself is a 14 question exam. There's also a bonus question in it. All of the exam questions are fill in the blank or calculation questions. There are no essays, there are no multiple choice, there are no matching, there's nothing other than just the work itself. It really should match up very, very well with what we've been doing for the past 4 weeks in class. The points breakdown, there are 59 points possible, but that includes the bonus question. You'll be graded out of 55. Um, and unlike the last exam where there was no designated bonus question, um, I just kind of graded overgraded. This one is going to have a dedicated bonus question. So that question will be completely optional, but I actually hope that you choose to do it because it should be one of the more straightforward questions from this particular bundle of chapters. Now, going on to the chapter by chapter breakdown here, first and foremost, what you should be able to see is that half of this exam comes out of chapter 8. And that is because chapter 8 is probably the one that we spent the most time doing. Chapter 13 is maybe close to that, but chapter 8 has a lot of kind of fundamental, foundational kinds of things on it that show up later on in other areas and show up in to some degree in chapter 13 as well. And so because of the high level of importance that we put on it, and because two of the four quizzes that this is based off of were on these topics, that's half of the exam right there. Now, what do you need to know out of this chapter? So, first of all, this chapter included chemical equations. So, you need to know how to determine the products of a chemical reaction. So, if we give you starting materials, you need to be able to look at it and say, okay, this is a double replacement reaction, and this is what I need to do. I need to assign all of the charges to all of the ions, switch the metals, create the correct products, and then balance the equation. You need to know how to identify the different types of reactions. So we went over 5 different types of reactions: the combination reaction, the decomposition reaction, the single replacement and double replacement reactions, and the combustion reaction. And then finally, you need to know how to balance chemical equations. Some of the problems in this test are going to be over really just that. From a stoichiometry standpoint, you need to know how to calculate molar masses. You should have some practice with that already. That was actually on the midterm, but here it is showing up again. You need to know how to convert. So how do I use the balanced chemical equation to turn moles of one thing into moles of another thing? How do I use the balanced chemical equation and the molar masses to convert between grams of one substance and grams of another substance. Now, to help along with that particular task, I am going to be providing you that mole map diagram. So if you remember from our lectures over that material at the time, what I'm talking about is this diagram in particular right here. So this was the mole concept map from a couple of chapters ago. That's not the right one. It's this one right here. This mole map concept is the thing that you need to be able to use, or at least I will be giving you this as part of that bundle of materials that you get on exam days. And you'll be able to use it as needed to do your work. So that's stoichiometry. From limiting reactants, you need to be able to use those skills of stoichiometry to figure out what reactant is the limiting reactant and what reactant or reactants are in excess. And need to be able to use that stoichiometry and limiting reactant material to figure out what the theoretical yield is for a particular product. So if I give you the mass of one reactant, can you turn it into the mass of one of the products? That's the theoretical yield. If I give you information about two reactants, can you figure out which one of those is the limiting reactant and then use that limiting reactant to figure out how much product there is? And then finally, out of chapter 8, we want to look at percent yield. Percent yield, remember, is just the calculation between the theoretical and actual yields. So it's actual over theoretical times 100%. You need to know the difference between the two so that you don't get it confused. And you need to know how to do the actual calculation. Good thing for you, that's on the equation sheet that you're going to be given. So it's just a matter of knowing what that equation is and knowing how to use it properly. Out of chapters 9 and 10, you can see this is less than 1/4 of the exam. We didn't spend a ton of time on these, but we spent enough on it to warrant at least a couple of questions. What do you need to know out of chapter 9? Well, you need to know about atomic orbitals. We talked about the 4 different sublevels, the S, P, D, and F, but you really need to know the 3 different sublevel shapes. You need to know where they can be found. So, for example, we know that the S sublevel, that spherical shape, is found in every single energy level because it is in the lowest of the energies. The P sublevel, those dumbbell orbitals, those are found in every energy level except for the first one. The d orbitals are found starting in the 3rd energy level, and most of them have that cloverleaf shape except for the one, which looks like like a bigger dumbbell with a ring around it. More importantly than that, though, we need to know how to do electron configurations. So I taught you how to do 3 different types of configurations. I'm really only going to test you over 2 of those types. The full configuration, where you start at 1s and go all the way down to whatever it is, or the noble gas configuration, where you start at the noble gas nearest to that element, and then you finish off the valence configuration. And in reality, you need to be able to write the full or noble gas configuration for any element in the first 5 rows of the periodic table or any ion in the first 5 rows of the periodic table. I'm not going to give you anything out of rows 6 or 7, like I promised you at the time. Anything that involves f orbitals, we were going to avoid because The number of exceptions and the actual configurations themselves are just a little bit too nutty, a little bit too above what we're trying to do here. So first 5 rows of the periodic table only. Out of chapter 10, Lewis dots. Being able to look at the periodic table and determine how many valence electrons there are. Remember, we use those cast numbering system headers, the A's. If the periodic table that we have doesn't have A's, we just know to take 10 off of any of the ones that are double digits. And that will give us the number of valence electrons. Being able to convert that number of valence electrons into Lewis dots for a given element. Being able to predict the most common ionic state based on the octet rule. And then finally being able to use those Lewis dots to connect elements to each other to predict the bonding of simple compounds like water or ammonia, carbon dioxide, the things that we focused on in class. Finally, chapter 13, solutions. A little bit more than a quarter of the exam, it's all calculation based. So from a concentration standpoint, do you know how to calculate the mass percent for a solution? Do you know how to calculate the molarity for a solution? This is stuff that we largely talked about almost 2 weeks ago, toward the end of the week. We also saw it in lab early last week. In addition to that, how do you dilute a solution? How do you use the dilution equation to figure out the concentration of a diluted solution? How to use the dilution equation to figure out how much of a stock solution to measure out in order to get you to a new solution with a different concentration. And then finally, solution stoichiometry or titration calculations, being able to use that modified dilution equation, the one with the ends on the bottom. And remembering that those ends correspond to the balanced chemical equation. So taking your ideas of stoichiometry and applying them to that particular equation so that you can use it properly and you can do the calculations that you need to do. So that's the breakdown. These are the things that you need to know. And where do you find these things? Well, obviously, it's in the notes from the past 4 weeks, but it's also been the subject of the last 4 weekly quizzes. So if you go back to mastering and you go back to the assignments that we've been doing for the past 4 weeks, and you go to the quizzes that we've been assigned for the last 4 weeks, you're going to find all of these concepts in those assignments. And so if you haven't done those assignments yet, this is a great time to do those. You can use the quizzes. If you still have attempts left, you can use those quizzes as kind of a practice run for some of the things that you're going to have to do on the exam itself. And if you don't, all that stuff should be available for practice through mastering anyway, so you can use it for practice purposes that way. Day of the exam. On the exam itself, I'm going to give you a periodic table because it's going to be hard for you to do any of the calculations involving stoichiometry without one. I'm going to give you the equation sheet. The equation sheet that I'm going to give you is the one that I gave you at the last exam. It's got all of the different equations on it, probably information overkill, but in a second, I'll show you in particular which equations are going to be the most useful to us for this exam. And I'm also going to show you that I'm going to give you that mole map organizer from chapter 8, which should help you with organizing your stoichiometry if you've been practicing on how to use it to do such. Day of the exam, you need to obviously bring yourselves. I would recommend coming a few minutes early, if possible, just so that we can get everybody in the room and we can actually start the exam at 1 o'clock instead of me having to go through and do instructions at 1 o'clock because people are still kind of filtering in. You're going to want a scientific calculator, a non-graphing calculator. If you don't have one, the Learning Lab will easily allow you to borrow one for the hour for our exam. And I would also bring pencils. Now, I know some of you like to and prefer to write in pen. Problem is, make a mistake in pen, it becomes a lot harder to kind of follow the mistake and figure out what it is that you're trying to do. It's a lot easier to erase a pencil as opposed to trying to figure out how to scratch through pen. So I would suggest bringing pencils. I would suggest bringing more than one just in case something breaks or something happens. I will have a couple of erasers on hand. So if something, really does happen and you need to erase a lot, these things are great. And I will have them on hand for you so that you can take care of any issues like that. But obviously bring more than one in case they break or they start to split or something like that. With the pencil sharpeners in our room being so loud, it's better if you don't have to use them while everyone else is trying to take their exam and concentrate and focus. So that's the information that you really need to know. That's the essential stuff for this mini exam coming up next Wednesday. Now, in addition to this, let's just go through the equation sheet itself. And so again, you can see there's a lot of stuff on here that we really don't need for this particular exam. Most of this stuff up here was covered at midterm. Most of this stuff is going to be covered on the third mini exam, the one that we're going to take in a couple of weeks, and we haven't even talked about this material yet. But what's going to be really important to us, if we can kind of highlight a few things of note here, right here is the dilution equation, C1V1 equals C2V2. In class, we use the M1V1, M2V2. But as I told you at the time, it's the same thing. In fact, the reason C is used here instead of M is just to avoid confusion over the fact that you don't have to use molarity. The other key equation for us is this one right here. This is our titration equation, which we can use for all of the solution stoichiometry problems that we are being given because they are all solution and concentration problems. The other thing here that is worth noting, look here, we've got our mass percent calculation here. The only thing that is not on this sheet is the definition of molarity. The definition of molarity is not on here, but on the day of the exam, I will allow you to write it in because I do think that it is important. And so we'll just write it in here for now. And so, again, on the day of the exam, I will allow you to write that one in, even though it's not there now, so that you can use it. So that wraps up our just breakdown of the exam itself. If you have any questions, if you are, wanting some more tips for how to study and how to prepare, feel free to shoot me an email or a text or come talk to me before or after class, and I'll be glad to give you more information related to those things. But for now, I'm going to sign off here and wish you a good day.